Sometimes we refer from one attribute of a table to an attribute of another table. The referred values might be the key of the second relation. The referred attribute in this case is called a foreign key. In these cases, the referral should make sense. For example, if you have a school database, you do not want to refer a non-existent student, or you do not want to refer to a non-existent bank account in a bank database. The constraint for these key attributes to make sense is called a foreign key constraint. For example, assume we have relations accounts and customers. The customers table has an attribute called account that has the account number for each customer. This attribute is used in table accounts and the account number attribute as a key of the table to uniquely identify the accounts. Therefore, account in the customer table is a foreign key to accounts. Another example. Remember our students table. Now, consider we have a relation named enrolled, and in this new enrolled relation, we want to have the information about the students' enrollments in courses. In this example, the SID in the students table is used in the STID in the enrolled table. This referral can be stated in the create table statement with STID references SID. This means that every value used in STID in enrolled should exist in SID in students. Note that all values of STID 1001 to 1004 exist in the SID attribute of students table. There is no need that every value of SID to be used in STID. For example, tuples with SID values of 1006, 1007, 1008, and 1009 exist in the students table, but there are no tuples with these STID values in the enrolled table, and that is okay. However, note that a value that does not exist in SID field of students cannot be used in the STID attribute of the enrolled table. The complete create statements for students and enrolled are shown here. For the rest of our discussions, note that STID is a foreign key to enrolled table that references SID from table students. It is part of the primary key for enrolled together with CID. Once we define the reference, the insert, delete, and update of our table entries will be effected. For example, inserting a tuple that is missing in the referenced value in the initial table will be rejected. Consider our students and enrolled tables. If we insert a tuple into enrolled that is using STID that does not have the corresponding SID value in the table of students, the insert transaction will be rejected. What about when we delete records? Deleting records from the table with the foreign key is okay. However, when we delete from the reference table, we may be breaking the reference. To maintain the consistency of the reference, we have three options. First, not allowing the delete. Second, removing the entries that are referencing it and therefore the possibility of inconsistency. And third, set the foreign key to null and therefore break the reference. Not allowing the delete of a reference tuple can be achieved using undelete restrict. For example, say we want to delete a record for a student Alice with SID 1003 from table students. Since STID 1003 has been used in STID in table enrolled and the delete operation is not allowed, this transaction will be rejected. To cascade the removal of an attribute to remove all of the entries that are referencing that attribute, we use undelete cascade. This will break the reference and remove the possibility of inconsistency. On the same example, again, We want to delete the record for student Alice with SID 1003 from table students. Since SID 1003 has been used in STID in table enrolled, and the delete operation is set to Cascade, this transaction will proceed and will result in not only the delete of the record for student Alice from a student's table, but all the records with STID value of 1003 from table enrolled, causing the removal of an attribute to set null the values of all the entries that are referencing that attribute could be done using onDelete set null. This will also break the reference by only removing the referencing value and not the referencing tuple. One more time on the same example. We want to delete the record for student Alice with SID 1003 from table students. Since SID 1003 is used in table enrolled, and the delete operation needs to proceed with set null on the referencing value, this transaction will proceed and will result in not only the delete of the record for student Alice from students table, but all the records with STID value of 1003 from table enrolled will have their STID value set to null. On a second thought, do you see any problem with this transaction? Note that a primary key is a unique index and its columns are implied as not null. So, although setting null satisfies the foreign key constraint, violating the primary key constraint here can cause rejection.